So welcome back. We have been talking a lot about roots of polynomial functions, and now we're going to start talking about graphs of polynomials and some basic properties. So before we talk about how to actually graph them, we're going to look at polynomial graphs and try and pinpoint some of the things that that you can identify about different graphs. Okay, so let's get started. I think the best way to start is actually just to start with a graph. So let's take, for example, the equations of these graphs are not so important. It's really the properties that we're looking at. Remember, you want to label your axes with an x and a y so that it's clear that we're not working in a complex plane where our axes would be real and imaginary. And let's take an example of some graphs. We'll take one graph to start with. I'll put it in a different color so that you don't confuse it with the axes. This is a function. Okay, so let's take this graph. And when we look at graphs, we're going to look at them from left to right. Now, I'm going to emphasize that in the next video, we're going to be talking about different other aspects of polynomials. And in that one, we won't be looking at it from left to right. In those examples, we'll be standing in the middle of the graph, as if we're like a little person standing in the middle of the graph, and then we look to our left and we look to our right. In this one, okay, when we talk about these properties, we're specifically walking through the graph left to right. And what we're going to pay attention to are the y values. Okay, the x values are increasing because we're going along the x-axis from left to right. We know that the x values are increasing there. So what we're going to be paying attention to in this part are the y values. And what we can do is we could break every graph into sections. And the way that we break it into sections is we look at the turning points, okay? So we're going to look at every time that every time that the graph turns. So there are a few places where this graph turns. It turns over here. So I'm just breaking this into intervals. It turns over here again. Then it turns again over here. Okay, what you're doing is you're essentially switching direction in each of these intervals. Okay, and what you're going to do is you're going to say, are the y values increasing? Are the y values decreasing? Or are they constant? So this is the first part of the graph. So let's go. Let's start from left to right. So here, this is starting from really way down. But as we walk in this interval, what's happening to the y values? Well, the y values are going up, right? We're going further towards the positive. The y values are going up here. So we would say that in this part of the graph, we're increasing. Then notice we come to the top over here. So we reach this turning point at the top of the increasing curve. Then we start going around. And now the y values are decreasing in this second interval here. So these are decreasing y values. Okay, so you're looking at the y values. Okay, so the next thing that we do is we're going down, 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 and then we see another turn, right? So think of yourself as walking. You're not just going to keep walking around the same path. You're turning, and now these y values are not changing. So we say that the y values are constant in this interval. Then we keep walking along here, and once again, we see another turning point again. And now our y values are increasing again. So in this interval, we're increasing. We keep going. All of a sudden, there's another turning point, and at this turning point, now we've started decreasing again. So they're only constant when the y values do not change at all. And then once again, we reach a turning point, and all of a sudden, now they're increasing again. Okay, so we have increasing, decreasing, and constant. So that's the first thing that we're looking at, is what's happening to the y values. The next thing that you're looking at are the minimums and the maximums. So the minimum is when we're going from decreasing to increasing. So like here, this is a minimum over here, okay? Or when we go from constant to increasing, we would also call this a minimum, okay? Or from decreasing to constant. This is a minimum. So your minimums are your low points. Your maximums are your high points. That's when you go from increasing to decreasing, okay? So think of this as, hey, I'm on top of a hill. So if I'm on top of a hill, I'm at a maximum. And if I'm in the bottom of a valley, I'm at a minimum. Okay, so let's write that down. So that's the second thing that we're going to be looking at. So a minimum is going to happen when you go from decreasing to increasing, or decreasing to constant. Okay, these are your turning points. Your turning points are either called minimums or maximums. In other words, we're saying at the bottom of a valley, if you're trying to think about it visually. But we also have our maximum. So our maximum is our y values go from increasing to decreasing. So on the left, it's an increasing. Whereas for minimums on the left, it would be a decreasing. So increasing to decreasing. Or increasing to constant. Okay, and then we have two different types of minimums and maximums. Either it's an absolute minimum or an absolute maximum. If it's absolute, it's the highest point in the graph for an absolute maximum. For an absolute minimum, it's the lowest point in the graph. Otherwise, we call it a relative minimum or a relative maximum, okay? So an absolute maximum is the highest y value, the greatest y value. Just ignore that. Whereas an absolute minimum is the smallest y value on the graph. Sometimes I've seen these called global minimums or maximums, but I'm going to refer to them as absolute. Every other minimum or maximum is called relative. Okay, I'm going to put this on the next page. And I will put a note here that not every minimum or not every graph has to have an absolute minimum or maximum. And this graph that I drew here is going to be a great example of that. Okay, so let's go back to this graph. And let's take a look at the minimums and the maximums. So the minimums and the maximums are going to be at the turning points. So we have a turning point, they're at the end of the intervals on these lines here. So we have a turning point, we see that we go from increasing to decreasing. So this over here is like the top of a mountain. So it's a maximum. Now it's not an absolute maximum because if we look at this graph, we do see y values that are higher. Okay, so this is a relative maximum. If we look at the change in the next interval, we see that we're going from decreasing to constant. So we know that that's a minimum, and it's a relative minimum, right? Because we do see y values that are lower in the graph. So this is a relative minimum. And then we see that we're going from constant to increasing, and I didn't put that in there, but going from constant to increasing is also a minimum. So these are relative minimums. And I'll add that in at the bottom. Okay, so let's just add that in here. So, or constant to increasing. And then the same thing would be here, or constant to decreasing. And you're going to see, because if it's at the top, if it's a top of a hill, if it's the top of a hill, then it's a maximum. So here, this is the bottom of a valley, right? We're going, and then after we make this turn, we're going up, okay? Okay, so then over here, we're going from increasing to decreasing. So once again, this is a maximum, so we're at the top of a hill. So then the question is it relative or is it absolute? And here you have to look at the arrows before you decide, okay? So this is actually a relative maximum because it's higher than this one over here. But there's an arrow, and this arrow says we keep going forever and ever, okay? So that means that this, if we actually followed this arrow, we would wind up higher than this point over here, right? We're going to wind up over here, and then we're even going to keep on going higher and higher. So this is also a relative maximum. And then we have one more turning point. Our last turning point, sorry, I'm going to put that in red just because I want you to see it clearly. We have one more. That's down here. That goes from decreasing to increasing. It's a minimum. But you have to look at your arrows. Make sure that there's no arrows on the end which are actually going to make this go lower. And there is. There's an arrow over here which is going to extend this. So this is a relative minimum. So there are no absolute minimums or maximums in this graph because of the arrows. So these are the things that we're looking at. We're identifying the intervals. Then in each interval, we're identifying is it increasing, decreasing, or constant. And then for the turning points, which lie on the interval line, we're saying, do we have minimums or maximums? And are they relative or absolute? Okay, absolute only if it is the highest y value, the greatest y value on the graph. So let's take another example and just identify the different pieces of it. Okay, so let's take this graph of the polynomial. And once again, we're going to divide this into intervals. So we're going to look for the turning points. So we see the turning point is when we're going down and then we go up, or we're going up and then we go down, or we're going constant, we're going just straight. So what you want to do is you want to break it up into intervals. The most typical mistake that I see is that people think of the y-axis as the end of an interval. So that's why I would encourage you just to do it in different colors. Okay. So if we identify our intervals, we go through each of our turning points. And we have 3 of them here. 3 places where this graph turns around. So let's look in the first interval. So in the first interval, going left to right, so remember we read left to right, our graphs go left to right. Don't pay attention to the arrow, pay attention to your y values. So your y values are going down as we go through this interval. So this would be a decreasing interval. Then we reach the end of the interval, and now our y values are going up in the next interval, right? Look at your y values, they're increasing. This looks like it could be at, let's say, -5. This looks like it could be at +2. This looks like it could be at +3. So our y values are increasing in this interval. In the next interval, we start at the top and then our y values are decreasing as we go, right? If you are following my mouse, then you're seeing that it goes down. So this is a decreasing interval. Then we reach our turning point. At our turning point now, all of a sudden, we're increasing, okay? And there is no place where this is constant. So don't get confused. Just because it flattens towards the top, that doesn't mean it's constant. Look at the difference between this graph and this one here. This is a real clear constant. If you have a constant, it's going to be really clear like this. You will see a flat line. So obviously I'm drawing these. On a test, you won't get a drawing. You'll get the actual graph from a program or something. So it'll be clearer. But these are turning points. You would not say that it's constant down here or up here. It flattens, but not completely. Okay, so these are decreasing, increasing, decreasing, increasing. There is no constant interval. Now let's go to our turning points, which are on our interval lines. And let's look at what types of minimums or maximums they are. Okay, so this goes from decreasing to increasing. Decreasing to increasing is a minimum. And it is not the lowest point on the graph. We can see that just visually. We don't even have to look at the arrows. We see already that there's a lower point down here. So this is a relative minimum. Now we're going to look at the next interval end. So we're up here. This is a hill that we're on top of. It goes from increasing to decreasing, so this is a maximum. Now we have to look at the arrows, because none of the other turning points are higher than this one. But if we look at the arrows, they point towards positive infinity, on both sides actually. And that means that this is a relative maximum, because there are higher points. You can see it even just at the top of this arrow. So this is a relative maximum. Then we come down here to the bottom. Okay, so this is going from decreasing to increasing. We're in a valley. This should have been moved over just a little bit. It's not quite going through the middle, and it should be. But this goes from decreasing to increasing. And we have to see, okay, well, this looks like the lowest point on the graph, but let's look at the arrows. Both arrows face up, which means they're going in the positive direction. They're never going to be below this. This is an example of an absolute maximum. Sorry, an absolute minimum. Okay, let's do one more. Okay, so the first thing that you're going to do is you're going to break this up into intervals. So we're going to look at all of the places where you're turning. And if you have to, just walk through the graph, right? Like follow your finger along the graph from left to right and say, when do I change direction? So we change direction first up here. Then we change direction again through here. And then we change direction again over here, right? You have to physically turn. If you were thinking about walking, you would have to physically turn your body. And that's it, okay? These are the places where if you were walking, you would have to physically turn your body to go into a different direction. So now we're going to identify increasing, decreasing, and constant. So in this one, as we go left to right, our y values are decreasing. Are increasing. We're going up. That's the first interval. The second interval, we turn around, and now we're going down. So this is a decreasing interval. Then we come down here, and now we have to go up again. So this is an increasing interval. Notice the y-axis is not the end of an interval, right? The y-axis, we just go right through it. It does not count as an interval. That's why I use the dotted lines, so that it's clear where our intervals are ending. Now we come up here and we turn our body, but our y values are clearly flat. Notice that there is a clear flat area. So these are constant. They're not changing. And then finally we turn around a last time and we're going down. So this is a decreasing interval. Okay, and finally we just identify our minimums and our maximums and whether or not they're relative or absolute. So here's our first turning point. It goes from increasing to decreasing. We're at the top of a hill. This is a maximum. It kind of looks like it's the highest point, but let's check the arrows. These both point down, so those y values are just getting lower. This one, it is higher than this constant one. I think that that's pretty clear from the diagram. If you're not sure, you can say that you're not sure, but on a quiz or something, it would be very clear. Okay, so this is an absolute. And on an actual graph, you would be able to actually look at the y values to be sure. I'm just drawing sketches right now. So this is an absolute maximum. Now we go to our next turning point. Our next turning point, we see a minimum here. Okay, so this is a minimum because it goes from decreasing to increasing. We're like in the bottom of a valley. Think of it like there are mountains on both sides of you. Okay, so this is relative. We know it's relative because we just saw the arrows that point down, which means there is no absolute minimum. And then we have two more turning points, and they're both at the top here, right? In both cases, we're turning and we're going increasing to constant or constant to decreasing. These are two cases where we have maximums, okay? We're at the top of a mountain here. So these are both relative minimums, relative maximums. And the only time that you have two absolute maximums would be if you have like this constant area that you see here, except this were lower down. If this had been over here, I'm going to draw this in and then I'm going to erase it. If this had been a maximum that went like this instead, right? This is now lower than that one. That would mean that this would be an absolute relative maximum and these would be absolute. That's the only time that you could wind up with two absolute maximums, okay? Is if your absolute maximum is like a constant. That's the only time that that would happen. And that's it for this one. So in the next video, you're going to talk about end behavior, which is it's looking at what is happening just at the very ends of the graph, that this is going down and this is going down, and it's ignoring the whole middle. Okay, and ultimately what that's going to do is it's going to tell you how to take a polynomial and graph it. Whereas what this is doing is it's telling you, let's look at the graph and see what's happening on the graph.